ఇక్కడే ఉంటుందబ్బా అదే మరి
Sir, is it audible? Negi, sir? You have muted. You have to unmute and you can speak now.
Yeah, now you're able to hear?
Yeah.
Hello?
Yes, it's audible now.
Okay.
Yeah, another 3 minutes to go. Then we can start.
Okay, but I'm not able to share. Should I share now slides?
Yeah, you can start. No
You
problem.
can share,
You
sir.
can share. You can first slide it. Yeah. Welcome. Who will be? Welcoming. You will speak. Yeah, sir, it's not visible.
That's what I was thinking.
Just you have to close this share screen and you have to open the PPT. On the PPT, you have to click. Your window, file window is visible.
That is not visible.
So you can stop now.
Leave meeting I will do again. Huh?
Yeah. No, share
No,
screen.
resume sir.
Stop while and then you have to share the screen fresh one and then you have to click on the opened PPT.
Is it okay now?
No, you have to stop now. It's not visible. You have to share
Stop share, I will
screen.
do.
You have to stop.
Okay.
Yeah. Okay. Now you have to first open your PPT.
Yeah. Okay, PPT is open.
After opening,
Share screen.
you can give some time to open.
Yeah, it is open.
Now, after opening the PPT, share screen and click it on the PPT. On the PPT window only.
It came.
Yes,
Now
it
came.
has come. It's visible. Yeah. Yeah, good afternoon to all the participants. I'm Dr. Raja, Associate Nodal Officer and Associate Professor in College of Horticulture and Forestry. So now for the formal welcome, I'd like to request um, Dr. Taso Yatung. She will be delivering this welcome address. And after this welcome speech, our resource person, Dr. P.S. Negi, he will deliver the lecture. Now, I request Taso Yatung for the formal welcome address.
Good afternoon, one and all. I welcome everyone to the second session of the webinar on post-harvest management and value addition in horticulture crops for budding startups. So we have with us very learned Dr. P.S. Negi sir, who will be speaking, who will be delivering the lecture and will be delivering the lecture on value addition of fruits and vegetables. So to begin with, let me give a brief introduction of him. So Sir Dr. P.S. Negi, he is a senior scientist in Department of Fruits and Vegetable Technology at CSR CFTR Mysore. He has obtained his bachelor's degree and master's degree from Jubi Pant University of Agriculture and Technology Pantnagar, with specialization in food and technology, and PhD in horticulture with specialization in post-harvest horticulture from Indian Agriculture Research Institute, New Delhi. He also did 1 year of PDF from Purdue University, USA in crop biotechnology. Sir has more than 22 years of experience in research and teaching, and he has he has 71 review papers in various national and international journals, 15 book chapters, 15 patents, 8 processing know-how, 64 abstracts in national and international symposium. He also has guided 51 numbers of MTech, MSc, BTech students and PhD scholars. He is specialized in post-harvest technology and biotechnology of fruits and vegetables, bioactive compound from natural resources and agro-industrial byproducts, non-thermal processing of foods. Sir has been honored with many awards. To name a few are the Raman Research Fellowship from Council of Scientific and Industrial Research in the year 2016-17. He was conferred with the designation of Certified Food Scientist by the International Food Science Certification Commission USA in the year 2013. He was bestowed with Dr. J.S. Fruti Award for the year 2017, Lalji Gudu Samag Nidhi Award for the year 2013, Professor Jeevan Singh Sidhu Award for the year 2007, and Young Scientist Award for the year 2004 from the Association of Food Scientists and Technology, India. He was elected for the professional membership of Institute of Food Technology, USA, in the year 2004, and also awarded with Boy Scouts Fellowship from the Department of Science and Technology for the year 2002. Okay, so may I please request our speaker to begin the session?
Thank you.
Yes, sir. Now you can start.
Thank you, madam, for the elaborate introduction. Am I audible?
Audible, your video is not visible, sir. Can you start your video?
Slide is not visible.
Pardon, sir?
Is it visible now?
Slides are, no, slides are visible, but your video, your photo is not
Oh, my
visible.
photo. Okay,
It's
my
like
photo. Okay, sorry.
Start your video.
Is it okay now?
Yeah. No.
Okay. Okay. First, let me thank organizers for inviting me to deliver this lecture on value addition to fruits and vegetables. I have just made a overview. Like first, I will talk about CSIR CFTRI, what it is doing, and what are the technologies we have. Then moving to value addition. Value addition can be done through processing. So I will be telling you in brief about traditional technology and value-added products developed in CSIR CFTRI from those technologies. Then moving to advanced technologies, what we have now started work on advanced technologies, which can be used for preservation of fruit and vegetable products. On advanced technology, on non-thermal technology, I will be telling about our experiments on 3 of the raw materials. Then what happens once you do processing, there is some kind of waste. So how to utilize that waste, some work we have done on making them to nutraceuticals that I will be presenting and so on. And finally, conclusion and future perspective. To start with CFTRI, as I think all of you must be aware that about CFTRI, almost 70 years back on 21st October, we will be celebrating our birthday, this 71st birthday. So we have there in for last 70 years, and we have done a lot of work in food journal, and any aspect of food is being worked here. We have 17 R&D department on different aspect of food, and among them fruits and vegetable technologies, one department. So coming to what is the mandate of CFTRI is processing of agri resources for value addition. Then we develop protocol for enhancing shelf life of perishable commodities. Then formulate low cost product for societal intervention. Then ensure food safety with advanced scientific methods. And then other mandate is to develop human resource in the area of food processing. In human resource, we have regular MSc program, then PhD program. Beside that, we take training courses for industry or for entrepreneurs, what we call skill development programs. Those are 5-week programs. Okay, and beside that, we train students, graduate or MSc students from other institutes. Then major work of ours is development of food processing industry by developing various food technologies for food processing. Okay. And if you have some new idea in food technology, you can join us for startup, and we have a very good startup facility. Okay. Now, when we say we support food industries, it is by the way of developing various technologies. We have almost 300 plus technologies in different areas of food. I will request you to visit our website, cftri.res.in, and you get this page. And whatever technology you are interested, suppose you are interested in bakery products, you will get what is the list of technologies, or if you are interested in fruits and vegetable products, you get the list. Okay. So these all are paid technologies. You need to pay some license fee, and then we demonstrate you how the product can be made. Okay. Beside that, we have some free technologies also for available for people. Okay, these are like we have a Amla Candy or Protein is one. These are freely available in our website. You can register and download and get the idea. But you can, how can you proceed for entrepreneurship development? Because they will be this technology dossier will be telling you what is the raw material required, where is the machinery, and what is the process of making. And if you are having interest, then we can demonstrate this technology to you free of cost also. But these technologies are paid technologies. For that, you have to contact our technology transfer and business development. But you can find the list. From this list, you can find if you are interested in any technology. And beside this, if you want you want to work on technology which is not listed here, also can be worked by in a project model. So now coming to my lecture, value addition. Value addition, as I told, can be through processing or through utilization of waste product, what is remaining after processing. So what is a food processing? Its basic definition: anything raw material you are going to transfer, you are going to transform it to a consumable product. Okay, and there are many ways like washing. These are very simple: washing, chopping, mixing, homogenizing, cooking. Then comes pasteurization or drying or freezing. There are many ways you can process a raw material to a food which can be consumed. Okay, and it can be done by either one or combination of operations. Okay, so when you do processing, what is the objective of processing? If we say basic objective of processing is to make it safe. Okay, it can be made safe by destroying pathogens or spoilage organisms, or some of the enzymes which can be active during storage, which can spoil the product in later stage. Okay. Other objective of food processing is to maintain the quality. Okay. So when you plan a processing, you just optimize the flavor, texture, color, and nutrition quality. So what happens there? Always you need to have a balance between microbial, or you can say safety, and then quality. Okay, and when I say traditional technologies, they are more tilted towards safety than optimizing the quality. Okay, when we talk of advanced processing methods, they will be more concerned with quality retention. But both will go hand in hand, because if product is not safe, it cannot be offered to consumers. Okay. So coming to traditional technologies, what we follow is most commonly followed technology is thermal processing. You must have heard about pasteurization, canning, aseptic processing, or latest is vacuum cooking or sous-vide cooking. Okay, pasteurization generally we do in many of the products, including, it is more famous in dairy products like milk, but in fruits and vegetables we do pasteurization, and temperature is always less than 100 degrees centigrade. And the major aim of pasteurization is to eliminate the pathogen, but it can activate enzymes and all other things also. But along with that, sometimes nutrients also can be destroyed. But in canning, where you inactivate all kind of microbes, it is higher temperature treatment. You do treatment for 120 degrees for 20 minutes. Okay, and everything is sterilized. Commercial sterility is obtained in case of canning. Aseptic processing is similar to canning, in the sense canning you do you pack the product and do retorting. Here you have to sterilize the product separately, and then packaging material separately, and then pack under sterilized environment. So this is one of the method where you use heat to achieve the food safety and to extend the shelf life.
Hello.
Yeah, hello.
Negi sir. Sir, actually slides are not moving, sir.
Slide is not moving. Now what slide you are seeing?
Yes.
Now which slide?
Title slide only, evaluation of.
Okay.
First slide, sir. Title slide only we are seeing.
But it is no slide you have seen till now, but you should tell.
No, sir.
So where should I start? Restart it? Are you able to see now?
You can no, sir, it's not moving.
Should again stop sharing and again start sharing?
Yes, sir. You stop sharing and again start.
Is it moving now? Not moving? Hello? Hello? Are you able to see now?
Yes, sir. Now it's visible.
Now
you move slides once. Yes, sir. Now it's moving.
Now it's moving.
Yeah. Now it's moving.
So I will Start from value addition directly here.
Sir, yeah. Value addition.
So as I told, value addition can be done through processing, and when you define processing, it is a method to transform any raw material to a product which is suitable for consumption. And you have many of the operations, what you call sometimes unit operations, to follow to convert the raw material to material which is suitable for consumption, and like washing, then cooking, pasteurizing, emulsifying, drying, freezing, and many more. So you can achieve processing by either one or more operations. So what is the basic objective in food processing is it's slight change now. Hello? Hello?
Sir, it's changed, sir. Yeah.
Object. When we do processing, we have certain objectives in mind, like first is food safety and second is quality. Beside this, processing will preserve the material for future consumption also, and then sometimes it gives you convenience of product also. Okay. So when you say you want to achieve food safety, mostly it is by inactivation of microbes. Okay, and when you want to try to optimize the quality, because what happens, you can achieve the destruction of microbes at very harsh condition also, but you don't want to compromise on the quality. That's why you need to optimize flavor, texture, color, and nutritional quality of food before defining a process. Okay. So coming to traditional process like thermal processing, it is very old process where you use heat to inactivate microorganism and also enzymes also, which can spoil the product during storage, like pasteurization, where you heat the product below 100 degrees centigrade to eliminate pathogen. Objective is here only to eliminate pathogen, not the all microbes. Whereas canning and aseptic processing, you are going to make it completely sterile by using still higher temperature than pasteurization. Okay? And sous-vide cooking or vacuum cooking is you achieve it at a slightly lower temperature of 65 to 95 degrees centigrade, and then but you store it lower temperature, because what happens in that temperature, all microbes may not be dying, or then you cannot keep it at a ambient temperature. Okay. Now coming to other form where you can preserve the product or you can process using low temperature. In morning session you heard about cold storage and low temperature. Okay. What that does, because of that temperature is reduced, so microbes cannot grow, as well as chemical reactions cannot be so fast. Means chemical reaction will take place, but it will not be as fast as a normal temperature. So when you are reducing the temperature or refrigerating a product, there is extension of shelf life by both the ways. One is microbe activity is going down. Second thing, chemical reactions are slowing down. So if you use further lower temperature, what we call as a freezing, where you are using temperature of -18 and below, okay, you can freeze by air freezing or cryogenic freezing or any other freezing methods. Okay. So what you do in that, you freeze the product, you freeze the water present in the product. Partially freezing is done, means partial water, whatever water is there, some amount of water is frozen. So what happens, water will not be available for activity of microbes as well as chemical reaction. Okay. And because the frozen product has to be stored at -18 or below, so no chemical reaction also takes place. But you have to be careful, because if temperature fluctuation is there, sometimes frozen products can also spoil. The other simple method of traditional method of preservation is drying. Okay, that is the most probably the oldest method and very easy method. You can dry the product by simply keeping in sun, or little bit advancement you want, then it is solar drying or then cabinet drying. Then there are many other forms of drying available. So what is the principle here? How you are preserving the product? Because you are removing the free water. So water activity of the product is going down, so microbes are not active at those water activities, and then chemical spoilage also is prevented. Okay. The other method which we use is a chemical-based food preservation method, where you use chemicals like what we call class 1 and class 2 preservative. Class 1 preservatives are natural compounds like sugar, salt, and what happens, there is no limitation. Legally, they are not limited for their use. You can use 1%, you can use 2%, or you can use higher. Only thing you have to take care, the product quality is not going to change by adding more or less amount of those preservatives. But class 2 preservatives are chemicals like sodium benzoate, sorbic acid, or your sulfur dioxide, but most commonly used in fruit juices. Okay, what happens? They have to be used within limit. Whatever is permitted by FSSAI, like SO2, you cannot use in any fruit juice more than 350 ppm. So you cannot use it more than that because they are at higher consumption, they are injurious to health. So these are the some of the traditional based technologies, and mostly these chemicals or they are used at hurdle approach. Means you must be aware, like hurdle race kind of thing. You create hurdle for microbes to grow, okay, by using chemical, by using low temperature, or by using high temperature. So you achieve the faster, you achieve the longer shelf life. So just to come, what are the value-added products based on these technologies developed in our department? Earlier I showed you list of our institute, but this is typical to our department, where they have developed, we have developed many of the uh, products based on these technologies. Like for, if you say fresh produce, there is a minimally process fresh fruits and vegetables are there, where more than 35 vegetables have been preserved. And this technology is very fast moving technology. Many of the companies like Big Basket also has purchased this technology, and they are successfully marketing their product. When you come to processed products, we have many of the processed products. Like in case of fruit beverage, we have like I have listed it, like open Rizwa beverage, or RTS lychee, watermelon, muskmelon, then blended beverage, vegetable beverage, beetroots, then banana pseudo stem, banana rhizome. Then there are many dehydrated powders like bamboo shoot powder, guava, custard apple, pumpkin, papaya. Then from under ketchup sauce, chutney and jam from many products like cherry sauce, wood apple sauce, sweet orange sauce. Then fruit and vegetable bar and candies from many products. Okay. Now coming to other kind of products developed, which we call as a nutraceutical and specialty products, like biofunctional beverage from mango ginger or spinach, elephant fruit yam, then from mangosteen, then from waste also banana soda stem powder, then bioactive extract from pomegranate, sea buckthorn, then debited product, then membrane clarified product, banana juice, then concentrate, vitamin concentrate, low sugar jam, then vegetable pasta, and biopreservation of sugarcane chunk. These are the technologies which have been, means these are there in the, if you go to our technology section in our website, you will find them listed there. Now coming to advanced technologies, when I say, as I told you, they are more focused on the quality retention. What happens when you use traditional technology like thermal processing? As I was telling, thermal processing will kill the bacteria, but at the same time, it can harm your nutrients. Also, nutrient quality can be diminished, or color can be diminished. Okay, so that's why this kind of non-thermal processing is coming in light recently. Like why people are preferring non-thermal? Because they give you fresh-like product, then they use less additive. Okay. Less additive, actually aim is to use zero additive, but sometimes you cannot preserve it for longer time, so some kind of additives are added. Then the products of non-thermal processing are of high quality, and because it is no thermal treatment is rarely used there. Even if it is used, the temperature used is very low as compared to your pasteurization or canning temperature, so less thermal damage is there. Okay. So I will just tell you about what are the technologies, non-thermal technologies in literature, and then I will show you what technologies we are using in our research. Okay. Like UV treatment. UV treatment is a very common treatment. If earlier time, if you remember, water purifier, they used to come with UV treatment. Okay, and what is the principle in UV treatment? UV treatment, you are passing the product through UV, like either it will be short UV from 200 to 280 nanometer, or medium UV from 280 to 320, or long wave UV, what you call UVA, from 320 to 400 nanometer. Okay, and the most effective UV range is UV wavelength is 254 nanometer, and effectiveness will depend on sample thickness, how thick sample you are passing through the UV lamp, and how far your sample is from the source of UV, and for how long you are treating the product, especially if you say fruit juice. Okay, but it can be done in solid products also. Like this is a UV lamp, you can expose the solid product and it can sterilize the surface of the product. Or if you have a liquid product, then you have a UV zone here, 2 zones of UV lamp are there. The product goes in. If you want to treat only one zone, it can come out. If you want to continue for longer time, then again it can be taken out from this outlet. So how UV treatment is helping in increasing shelf life, as I told, if you say safety parameter, these are the experiments on tender coconut water where they have seen if source is 1.65 mm far away and for 14 seconds at 254 nanometer, then there is a reduction of E. coli as well as Listeria monocytogenes. So if you say quality wise, the enzymes which can degrade the quality of the product during storage, if 90-minute treatment is given for 1 minute sample, 1 mm sample thickness, and the distance is 8.6 centimeter, then there is almost 50% reduction of PPO. PPO is a polyphenol oxidase enzyme, and peroxidase enzyme is reduced to 66%. So what I am trying to impress you here that it can be used to achieve both safety as well as to retain the quality of the product. So what happens, UV treatment works on the principle of thymine dimer formation. What happens once you treat a microbe, treat a sample which has a microbial contamination, microbes DNA will be altered. Okay, so they cannot generate again. Okay, but what happens once you remove UV treatment, there is something called as photoreactivation where this thymine dimer can be corrected and again they become active. Okay, so to overcome that, the pulse light treatment is developed. This also is almost similar principle. This is the range of pulse light what we pass the sample. It ranges from 100 to 1100 nanometer, but most of this is 50%, 54% is in UV range. Okay, so again UV principle is applied at this 54% of the time. Then it goes to visible range where photoreactivation can take place, and then IR range. So what happens, photoreactivation takes place and there itself, and then again it passes through again to UV range. So again it is getting inactivated. Okay. So efficacy of pulse light treatment again will depend on layer depth, then distance from source, and then one more parameter comes here, pulse. How many pulse per second or per minute we are passing through. Pulse means one pulse will be from 100 to 1100 nanometer. So if it is instrument is giving you 3 pulse means 3 times per second it is passing from 100 to 1100 one time, then again comes to 1100 range, then 1100, then third time 100, then 1100. Okay. So that way it is getting treated 3 times if it is 3 pulse. Okay. So that also becomes a factor to sterilize the product. Okay. So these are this is laboratory setup where you have a xenon lamp and then product is exposed here. Okay, and then commercial unit available is from Xenon Steri Plus, okay, which gives you 3 pulse per second and product can be. So if you see efficacy, it's slightly better than what I told our just UV treatment. You can see 5 mm depth, 5 centimeter distance is kept, and 240 flashes are given. So 240 flashes means if it is 3 seconds for 3 pulse per second, means it comes for 80 seconds. So there is reduction of quite good reduction of E. coli is taking place. Okay. Again, the reduction and enzyme activity will depend on product. Also, if you compare these two, apple juice which has slightly higher pH than apple cider, you get less reduction as compared to apple cider because here pH also of the product also matters. Okay. And if you see the PPO activity in potato, 2 to 5 flashes, 3 joule per centimeter square has given complete inhibition of PPO. But for other enzymes, it was not effective. Okay. So that's why I just want to clear your doubt that it is not only a product, it is also which kind of enzyme or which kind of microbes you are targeting will also means the efficacy will vary depending on those parameters also. The other most common method used is filtration method. Like nowadays, we drink water mostly using this RO or ultrafiltration water. So these are various kind of filtration methods, like microfiltration, where the membrane like cellulose nitrate filter is there, where pore size is very small and a product can be passed through microfiltration. Or you have a osmosis or reverse osmosis, where you have a semi-permeable membrane and then you get a clarified juice, okay, or pure juice. Or you have ultrafiltration. Again, ultrafiltration membrane, still lower size is there, cutoff is less, and then your feed comes and then through ultrafiltration whatever is passing through it is collected, and whatever is not able to clear that, it goes to drain. Okay, then style advancement is on forward osmosis, where it again reverse osmosis and forward osmosis. There are two processes here. You have one, what happens, you have a solute and you have your product. So your feed product goes and it is getting concentrated by osmotic agent, because the water from this feed, which has less concentration of osmotic agent, will pass through the osmotic high concentration, and then it will getting concentrated. So it is used for concentration or concentration of fruit juices or making concentrate. Then if you see efficacy of filtration, again, like two-stage filtration using cellulose nitrate membrane of 0.2 micrometer, you have, there is no visible growth was seen. Or if you add again L-ascorbic acid, some kind of additive they have added, so again no microbial growth was seen. Then in case of enzyme, 96% reduction of polyphenol oxidase was seen by using 20 kDa membrane for ultrafiltration. Carbonation, we all are aware of sparkling drinks. They all are carbonated. Okay? How carbonation makes it safe? Because carbon dioxide has a bacteriostatic effect. It can decrease the intracellular pH, or it can inactivate the cellular enzymes. Okay. And then by lowering the pH, you can still increase the, it lowers, because once carbonic acid is formed, when carbon dioxide is passed through the sample, pH will be lowered. So again, it becomes more difficult for microbes to multiply. This is a schematic for carbonation treatment. You have a concentrate. Okay, you pump the concentrate, then you pump the carbon dioxide, and then they are mixed, and then they are dispensed. Okay. So a slightly advantage on carbonation, because carbon dioxide is not readily, it will not mix with the sample. So sometimes pressure is used, okay, where pressure transducers are used, and then pressurized carbon dioxide is passed to the sample. So what happens? The efficacy is higher. Okay. If you see efficacy, like if slight pressure, 12 megapascal pressure is given, and then 4 degrees centigrade 30-minute treatment is given. So 5 log reduction of mesophilic bacteria, 7 log reduction of total coliform, means it's a very high reduction, and product becomes safe. But it was not found very effective against the pectin methyl esterase in peach juices, like only 20% inactivation of the PME was achieved. Okay. Now other new technology coming is pulse electric field. What happens if you pass a short pulse, means in microseconds of high voltage. Okay. So you have a like treatment chamber where you have a high voltage pulse generator is there, and you pass the sample through this pulse generator for a very small time, microseconds, but voltage is very high. If you want to kill the microbe, the voltage has to be more than 10 kilovolt per centimeter. Okay. How microbe is killed? Here the microbe is passing through the electrodes, and you can see electroporation can take place in microbial cells. So once electroporation takes place, means the cell membrane of microbe is getting, pores are being formed there. So the cytoplasmic content can come out and microbes can die. Okay. Then it has got it has got the industrial application in many fields, like not only electroporation, it can, because this electroporation can be means advantageous for moisture distribution to maintain osmotic flow. So it can help in texture modification of the product also. It can help in freezing. Then it has been used for solvent extraction. Because of this electroporation, drying rate is getting increased. So it can be used for drying, and then dewatering also it can be used, because of pressing and dewatering can be done. Okay. So it has application in like fresh fruit distillation, and then fresh fruit, then it has a dairy products, then fruit juice or meat products or fish and meat products, as well as for processed product also. The application was like to remove acrylamide from the potato chips, potato French fries. Okay, so those kind of application are coming up for PEF. When you see efficacy, like again the condition, if it is 31.2 kilovolt per centimeter, you have a 3 log reduction of bacteria was found. Or if you see 0.8 kilovolt per centimeter, it was able to decrease 66% of polyphenol oxidase activity. Okay. but it has no effect on peroxidase. But polyphenol oxidase is the major enzyme which can cause browning of apple juice during storage. The other upcoming technology is cold plasma. Plasma is nothing but this is the fourth stage of the matter. What you call, it is solid, liquid, and gases. Then plasma is the fourth stage. Okay, that is it is composed of photons, ions, atoms, and free electrons. Okay, so what happens? There are free radicals are there. So free radicals can react with microbes, and they can cause oxidation, and microbes can be destroyed, or they can be inactivated. Okay, the schematic, like you have a again high voltage electrode is there, and then dielectric. There are many kind of barrier discharge can be used, but generally dielectric barrier discharge is used to generate the plasma, and the product is exposed to those plasma generated, and then there is an inactivation of microbes as well as enzymes are inactivated. Okay, and you see industrial application, there are many, like I told, microorganism can be inactivated, stress produce crystallization can be done, grains also can be then fish or dry fruit crystallization, then meat product also can be used, and it has been used in removal of pesticide also. There are again similar kind of efficacy depending on the what volt, like 23 kilovolt or 28 kilovolt, you will have a reduction in enzyme activity. If 23 kilovolt is used, the half maximum reduction time was 1.67. If you increase the voltage, it was reduced to 1.18. Similarly, if a 90 kilovolt for 2 minutes caused 1.2 log reduction of salmonella, but when it was combined with citric acid, the log reduction was very high. 5 log reduction could be achieved. Okay. Now coming to other upcoming technologies, ozonation. The ozone, it's a strong oxidizing agent. So by oxidation, it can oxidize the cellular components and then can kill the microbes. So this equipment, what is in our lab, we are using it. It's a kind of industrial grade only, like you have oxygen concentrated, then ozone is generated by corona discharge method here, then which can be analyzed and can be passed through the sample filled in a column if it is fruit juice, or it can be sparged in the product also if you want to do decontamination of fresh produce. Okay. Then remaining ozone is can be passed through ozone destructor. Okay, because you cannot leave ozone just like the atmosphere, so ozone destructor will again destroy it and then can be converted to oxygen. So there are, like I told, there are many upcoming applications, like it can be used for sanitation, then it can be used for disinfection. Water, it is used for disinfection also, then surface removal of pests also, then food packaging, material sterilization, then decontamination and surface sterilization of the products can be used. If you see efficacy, then this is our experiment only, we can get like at 1.2 gram per hour rate for 5 minutes, you can completely inactivate the various enzymes also. And then you can get almost, this is in this experiment was done in tender coconut water, where initially itself very less contamination is there. So almost complete inactivation of microbes also, complete removal of microbes also was achieved by this rate. Other technology is ultrasonication, because of sonication, there is formation of cavitation is there, and then formation of free radicals is there, which can cause the destruction of microbes. Okay, this is our laboratory model of sonicator. This is ultrasonic generator. Then because during sonication, because of very high power, there may be heat generation, so you need to cool this cool the chamber where your product is kept. Okay, so you can, and this is an industrial scale where you can, these are the transducer, and here is a probe, you can pump the product here and then again can be collected by after sonication. So sonication also has a large number of application in food industry, like it can be used for, most common uses for extraction of compounds, like extraction of nutraceutical compounds from any of the material. Then it can be used for drying or brining of the marinated product. Then filtration, then it can be used to help in freezing or thawing. and then installation and then meat tenderization also can be done using ultrasound. If you see the efficacy, then there is more than 75% reduction of polyphenol oxidase and peroxidase at 20 kilohertz at 60% amplitude and 15 seconds. Okay, these are the parameters which we need to control how much kilohertz we need or how much amplitude, because the equipment will go from 10 to 90% amplitude, then timing you can vary. Okay, and if you see the reduction of microbial cells, 2 log reduction was achieved in coconut water. The other and most important non-thermal technology is high pressure processing. High pressure means it's like 100 to 900 megapascal pressure can be used, and it can be used for a few seconds to 20 minutes. And the beauty is here is that pressure is isostatic. It is equivalent, means it is equal pressure from all the sides. Okay, and that this high pressure can break the hydrophobic and electrostatic bonds of protein, so that enzymes can be inactivated. But at the same time, low molecular mass compounds like vitamins and flavors are unaffected by the pressure. Okay, this chart just to tell you how much pressure we are going to use. If you see atmosphere pressure is 1, and autoclaving, when people are using, they are using 15 psi. But when we talk of high pressure processing, it is almost 50,000 to 1 lakh psi pressure is being used. Okay, and then it has application like high pressure can be used for preservation of the product, especially in case of low acid foods, where pressure assisted thermal distillation can be achieved, or we can do pasteurization of the product, and shelf life extension can be achieved using high pressure processing. Pasteurization will use a lower range, like up to 350 or 400 megapascal, but if you need higher distillation, then we may have to go to 600 to 700 megapascal pressure. Okay? Then it can be used for, it is used for transformation of the protein. Like what happens in protein when it is, especially in meat protein, it causes standardization of the protein at lower range, 100 to 200 megapascal. And then it can be used for seafood value addition. Mostly it is used to separate the meat part from the bone parts or skull part of the seafoods. This is the equipment what we use in our laboratory. This is 2-liter capacity equipment. It has a pressure control unit and temperature control unit. What happens, this is the treatment chamber here where water is filled and it is pressurized through air compressor and intensifier. Okay? And then these are, our unit is 2-liter unit, but there are commercial plant maker like not in India, but in other countries, like Abur is one of the commercial manufacturer. Then Hyperbaric is another manufacturer. They make very big equipments that can treat up to 525 liter. Their treatment chamber is 525 liter and then up to 525 liter. And then they can be kept in parallelly, they can be operated also. Means if you want higher volume, then if you use 2 units, it becomes 1050 liter per capacity it becomes. And this is the hyperbaric data where they say the high pressure processing equipment they have installed for fruit and vegetable processing for 21%, and juice and beverage 23% plants they have installed, like meat 19%, seafood 7%. How efficacy? This is very efficient. As I told, if you use higher pressure, you get better log reduction. Like 600 megapascal, you can get 6 log reduction. And similarly, if you for inactivation of enzymes which can spoil the quality during storage also can be achieved at pressure 300 megapascal in 5 minutes. 45 degrees centigrade, if it is supplemented, it becomes in 300 megapascal only. But if you don't need to use heat, then slightly higher pressure can be required, like 500 megapascal pressure is required. Now coming to what our experiment we have done for value addition or preservation of different raw material, like here I'm showing wood apple juice. Okay. So like we have treated with ozone, and then there are parameters like we have standardized from 20 to 80 gram per meter cube from 5 to 20 minutes ozone was used. Then ultrasonication power is fixed 20 kilohertz. Then amplitude was varied from 30 to 70%, and then 5 to 10 minute treatment was given. Then high pressure processing, it was 350 to 650 megapascal pressure was used and time was given for 1 to 5 minutes. Okay. So how do we standardize the process? Like we have process targets. We aim to inactivate PPO and POD. Then we see that how much bacterial count or pathogen count it is going to reduce. Okay. And we say then physicochemical parameters are also checked, especially Browning index, what is happening during storage. And then nutritional and nutraceutical parameter, whether it is affecting ascorbic acid or antioxidant capacity also is measured. Okay. So I will just show you results for this product. Like if you see the here, this A means amplitude 60% amplitude, time for 10 minutes, and temperature was maintained at 50 degrees centigrade, whereas here temperature was maintained at 20 degrees centigrade. So once you treat it and then you have a when we saw the plate count, if you see the FSS standard, it should be 1.69 log, below 1.69 log CFU per ml. Okay. So except this case where we have used ozone 60 gram per meter cube, and for 5 minutes, initially count was higher than, means it was crossing the limit of FSI, but otherwise during storage also it maintained. Okay. And when we checked high pressure process RTS, there was no growth was seen either initially or during storage also. Okay. And then when we see ascorbic acid retention, you can see ascorbic acid retention was, if you compare, these are like ultrasonicated product, these are ozone treated product, and these are pressure treated, like 350 megapascal for 10 minutes and 650 megapascal for 10 minutes. Okay. So the ascorbic acid content was higher. We found it was higher in high pressure treated product, and which maintained during storage also for 28 days storage also. Ozone treated, it was expected because ozone is oxidizing agent and ascorbic acid, you know, it's very prone to oxidation also. So ozone treated gave less ascorbic acid. Okay. When we saw the nutraceutical content, total phenolic content, again it was lower in ozone treated samples, but higher in pressure treated products. So similarly, because antioxidant activity, here we have expressed like IC50 values. So lower the IC50 value, better the antioxidant capacity. So among all three, again pressure high pressure treated sample gave us higher antioxidant activity, and lower the pressure, better the activity was obtained. Because what happens, ultimately the antioxidant activity was dependent on the phenolic content, and in this case phenolic content was higher, so we got better antioxidant activity. Okay. So moving to other kind of product like sugarcane juice. Here, because sugarcane juice was not, we are not able to control the growth with a single treatment, so we have tried different hurdles. Okay, like ozonation plus lactic acid, we have tried, then heat, HPP plus heat or preservative, then ultrasonication plus thermosonication. Again, thermosonication means we are we are doing ultrasonication at slightly higher temperature. Instead of maintaining low temperature, we are maintaining around 50 degrees centigrade. So I will show you not the result, but the major result for ultrasonic thermosonication. If we treat sample at 50 degrees centigrade, we got higher log reduction in comparison to at 10 degrees centigrade. Okay. So that's why I told you, if you are not able to control the growth by by single treatment, sometimes you may have to do hurdle approach, where here we have seen like sugarcane juice alone was giving high count, but once we combine with temperature of 50 degrees centigrade, the count got reduced. Okay. Same thing happened with ozone. Again, sugarcane juice was not able to give better quality just with ozone. Then we combined with lactic acid, then we saw there is a reduction in total log counts, as well as there is higher reduction in, if you see this ozone plus 0.5%, here it is better reduction in enzymes which are related in the quality of the product. Okay. If you see the sensory profile, like ozone and lactic acid treated juice gave, this is sensory profile. This is compared with the fresh juice. Every time we get fresh juice, this is after 28 days of storage at 5 degrees centigrade. If you see the overall quality of fresh juice was very high, but the ozone plus Lexir treated juice gave you around 9 score, which is considered as a acceptable. Similarly, in case of high pressure treated juice after 28 days, high pressure treated, again, the highest quality was for fresh juice without high pressure treatment, but quality of HP plus KMS also came very close to that, means around 9 score we got. So we concluded that after 28 days also the juice is acceptable for consumption. Then preservation of tender coconut water using, again, non-thermal treatments. Here directly we can achieve by without any hurdle, like HPP 350 to 650, then ozonation 20 to 80 gram per meter cube. And if you see the sensory quality of tender coconut water, here it is ozone treated. Okay, if you see overall quality, again it is giving around 9 score ozone treated, okay, which was equivalent to heat treated after 21 days. And if you see high pressure treated, here again we are getting almost 9 plus score for tender coconut water, which was treated with 500 megapascal pressure at normal temperature without using heat. Again, 9 score of 9 was obtained after 28 days storage. Okay. So what we find that it can be preserved, and this, if you see, these scores are very similar to what is commercially, like 85 degrees centigrade and 10-minute pasteurized juice, or here heat treated. If you see, it is almost similar what our non-thermal treatments are giving. Okay. If you see the literature survey, what for non-thermal treatment, what kind of self-life people report, like ozonation, if you see, it varies from 12 to 128 days depending on the type of non-thermal treatment is used. Okay. So like our results are like ultrasound treated, we could get life of self-life of 14 days. Ozonation, we could get 21 days, and high pressure treatment gave us 28 days self-life at low temperature. Okay. But depending on the treatment, like if you see pulse electric field is giving 25 days, or if you say microfiltration with other additives, you can get 46 days, or if you combine the plant extract with PEF, you can get 120 days self-life in literature report. But if you see commercially, these are the market samples of non-thermally treated product. This is from raw pressure tender coconut water. They prescribe they give self-life of 21 days, and this is microfiltered. This comes for 15 days. Okay. If heat treated, again, this is available paper boat, and Cocogel, they generally give 90 days and 120 days self-life. But high heat treated like Tetra Pak, this is available in international market, Kirkland and Vita Coco, they give self-life of more than 6 months. Okay. But only thing, quality wise, the quality which we achieve in here in high pressure treated is much higher than what you see in that retort packed juice. Okay. So now coming to what are the challenges in non-thermal processing, like as we are discussing, the self-life was getting very less because it is in just weeks, not in months. So that's what the great challenge, because you need to maintain the quality and health benefits without using heat or without using any other additives. Okay. This is one of the challenge to extend the self-life. Okay. And then other thing is, as non-thermal treatment, actually treatment is not costly, but the initial cost of equipments are slightly higher, which prohibits their use. But nonetheless, there are many players in the global market for non-thermally processed product. Like you have Hyperbaric tool, Agur is there. Then if you say Ilia Technology, Pulsemeter, they are in PEF. And then there are many products available globally, like in food, beverage, and pharma, and then meat, poultry, and seafoods, fruits and vegetable and dairy products, juice and carbonate juice. They are very common in global market. If you see in Indian market also, I could not find other products, but only high pressure treated products. There are 3 companies in Indian market. These samples are available in the market by Raw Pressuries or Second Nature, and this is by Encold. So, and these 3 companies which are marketing different kind of fruit or vegetable or mixed juices are treating the product by high pressure processing. So what I want to say about non-thermal technology, this is a very promising technology for value addition to the product, and it's now coming in India also. Now coming to second part of my lecture, where once you have processed and then how you are going to utilize, because as I told, value addition can be done on the waste also, because when you prepare product for processing, there are huge amount of waste. This data, although slightly older, it is from a published paper of Leftenberg 2009, but it clearly shows your production and your waste is almost 12% of what you are producing. So this is not a loss, this is just waste. This can be utilized. Okay, and then this waste we have tried to utilize in our experiments. How it can be utilized, something you call nowadays circular economy, where you can have a recoverable loss and non-food grade biomass loss also can be there. When you have a fresh produce, you are going to use different post-harvest preservation, fermentation or processing, you are going to get a product. Okay, I get food, beverage or dairy supplement. Okay, now whatever is remaining, whatever is not used for preservation can be again recovered and can be made a byproduct, or it can be added to the original product and can be consumed. But whatever cannot be used, which has gone waste, they can also be used for like value addition by development of bioactive or functional ingredients or any other thing. Biofuel also can be used. Okay. So coming to what we have done, we have done this one, value added bioproducts or bioactive compounds. We have tried to identify from different agro-industrial byproducts or from underutilized fruits also. So what are the bioactive compounds? They have means they are secondary metabolites, have influence on human physiology. Okay? Like they can either be antioxidant, they can give anti-inflammatory activity, they can have antimicrobial activity, they can show anti-cancer activity, and then they have cardiovascular property, anti-obese, many kind of anti things you find attributed to these kind of bioactive compounds. Okay. So, and what are bioactive compounds in fruits and vegetables? There are more than 10,000 compounds. This is a very simple classification, like they can be classified as carotenoids, phenolic compounds, glycoalkaloids, and among carotenoids also lycopene. There are more than 600 carotenoids known till date, and then lycopene, beta carotene, alpha carotene, zeaxanthin, many are there. Like then there are phenolic compounds, hydroxycinnamic or hydroxybenzoic acid, and then flavonoids, and then many are there. I will show you in next 5 slides. I will show you this classification. Okay, like what are those compounds? Like you say, terpenoid bioactive compounds. They are like monoterpenes or diterpenes, triterpenes, tetraterpenes. Okay, tetraterpenes comes with chlorophyll, either means carotenes like alpha carotene, beta carotene, or they are xanthophylls like cryptoxanthin, zeaxanthin, and these examples pertain to vegetables, but these are also available in fruits also. Now coming to phenolic compounds, there are, as I told, there are more than 10,000 phenolic compounds available in the literature, and now they are classified like natural monophenols, then polyphenols, or then you have tannins, then you have isoflavonoids, flavonoids, phytoestrogens, then hydroxybenzoic and hydroxycinnamic acids, and phenylphthaleinoids. Okay, and others like capsaicin or gingerol also are available. Then flavonoids, another class is flavonoids. They are simple flavonoids, flavonols, flavonones, and then flavontriols, flavanonols, and then anthocyanins. These are the examples of various bioactive compounds present in fruits and vegetables. Then glucosinolates. There are many kind of like indole, then organosulfides, organosulfur compounds, or the glycone derivatives, or then precursor to isothiocyanates also are available. Okay. And then when they are not classified, they are called miscellaneous bioactive compounds, which vary from cholines to coenzymes, ubiquinone, then chlorophyll, then amines, then betalins, and other organic compounds are also available. So this is just the list to show you there are various kinds of bioactive compounds present in fruits and vegetables, as well as their waste materials, okay, which can be utilized. Okay, so now when you want to use fruits and vegetables bioactive compounds, so what are the different strategy we have to follow? Like first thing is selection of raw material. So we must know which, like suppose you want to extract lycopene, you may have to choose a raw material which is rich in lycopene, like tomato. Suppose you want to do phenolic acid, then you have to choose other kind of raw material which can yield the phenolic acid. Okay, so once you choose the raw material, then is extraction. There are many extraction technologies which can be used. Then third thing comes purification and identification, where you characterize the compound, then you determine the functionality, like whether it has some particular function. Like I told in my initial slide, every bioactive has some kind of function like antioxidant or antibacterial, or it is anti-cancer. So once you determine the functionality, then it can be used to make a nutraceutical functional food. Okay. So like when you go for extraction and identification, there are like first step is sample preparation. You can dry the sample either by air drying or you can freeze dry. Okay. Once you have a sample prepared, then you have several kind of extraction techniques, like you have a Soxhler extraction, you have solid liquid extraction method, you can use liquid extraction, you can use sonication, you can use microwave assisted extraction. Okay. Once you have extracted, then cleanup or isolation goes, where you use various kind of chromatographic techniques like column chromatography or thin layer chromatography, and then final identification is done by instrumental analysis, where you have like various kind of technique, like either UV spectrophotometry or fluorescence, or you have NMR or MSMS, or you can use GC or capillary electrolysis can be used to identify a particular compound which is present in the extract what you have extracted. Okay. Or if you know the compounds, then you can directly go for identification and quantification. Like if you are looking for stilbenoids, like in grapes, resveratrol, you can do by GC, HPLC, NMR, or tannins, HPLC can be used, or curcuminate, TLC, or HPLC or C can be used, or lignans and flavonoids. You can use NMR, TLC. These are the common techniques. NMR, GC, TLC, HPLC can be used for identification of many compounds. So once you have identified the compound, then the next step is to know their functionality. And functionality can be known by either in vitro or in vivo assay. So in vitro assay means what you do in test tube in lab. Like there are many kind of assay what can be performed for knowing their functionality, like antioxidant capacity. You have like ABTS assay or ORAC assay or DPPH assay. Then you can know their antimicrobial activity, like antibacterial activity. You have broth or agar dilution method, well diffusion method, disk diffusion method. Then you have anti-mutagenic activity, where you use Salmonella strains, Ames test commonly it is called. Then anti-cancer activity by MTTSA, anti-diabetic activity or anti-obesity activity, or you can go for anti-Helmintic or anti-aging, or the primary screening for toxicological evaluation can also be done by various in vitro methods. So once in vitro method is over, the next step is to do in vivo assay, means in any of the live cells, like you can choose eukaryote or multi-invertebrate or vertebrate. Like once you can do like C. elegans is most commonly used model, or fruit fly. Then rats can be used different kind of like Wistar or Sprague-Wedelgh rats, or rabbits, or still higher, pig can be used, dog can be used, rabbit can be used. Okay. Then amphibians can also be used. Okay. The next step is once you develop product, then clinical trial has to be done. That I not. So now I will tell you how we have done in different 2-3 products, different kind of extraction. Like you must be aware of like Garcinia. There are different species of Garcinia, Garcinia cambogia, Garcinia cova, and Garcinia indica. Okay, what is the Garcinia cambogia? Mainly is used for hydroxycitric acid production, which is a means a pharmaceutical compound, which is anti-obese compound used in weight loss. Okay, so what happens once you extract SCA? There is a waste which we have utilized, like we have done by different filtration technique and combination of distillation and extraction by different compounds. We have isolated some of the bioactive compounds, which has shown like antioxidant and antimicrobial and anti-mutagenic activity, means they can be probable anti-carcinogenic compound. So this we have been granted a Indian patent. Then other raw material what we used was turmeric, which was you are well aware that turmeric is used for curcumin production. So once you remove curcumin, there is something called curcumin removed turmeric oleogen, what we call CRTO in short. And this is a waste. They use it for fuel purpose in the same factory. So when we have by combination of different extraction and distillation and chromatography method, we have found a turmeric oil fraction which was rich in aromatic terminal, and that has been granted as Indian patent again. And what happens, this aromatic terminal rich fraction has very high bioactivity as compared to hexane extract or CRTO, and those bioactivity in terms of antioxidant activity. Other product is sea buckthorn, what is commonly called as lay berry. Here is the picture, and these berries are used for juice production, but seeds are not utilized. Okay, so we have used again extraction of bioactive compounds from these sea buckthorn seeds, and demonstrated that the process was yielding very high bioactive compound, which was high in antioxidant, antimicrobial, and antimutagenic activity, and for this we have been granted a US patent. Similarly, we have used many kind of waste material like pomegranate and citrus peel. Cinnamon fruit nobody uses, only bark is used. So cinnamon fruit, it goes waste. So then moringa seeds we have used, Dillenia indica bean, or then coming to underutilized fruit like Suriname cherry, Kadamba fruit, wild apple fruit, wild banana, spine gourd, and java apple we are using for extraction of these bioactive compounds. Okay. So now once you extract, it is not like that you can directly add in the product. So you need to ascertain the safety aspects of use of these bioactive ingredients. In what you can argue that in fruits they are available because they are natural, but what happens when they are available in fruits, they are in very small concentration. But our extraction procedure causes concentration of these compounds. So some of these concentrated compound can be toxic or they cannot be safe to consume. So that's why you need to go to follow the safety procedures. And to follow the safety procedure, International Life Science Research Institute has given a very nice decision tree where you need to answer some of the question like, is the ingredient or product a botanical traditionally used in food in the same form as in the proposed application? Okay. If your answer is yes, then again you need to say, well, will the proposed use lead to a significant increase in intake compared with a high consumer of a traditional ingredient or product? Whether a person will end up eating very high amount. If it is no answer, then your exit point is A. Exit point A means you need only these 4 information, like 1 to 4 information to add to the product, like specification of the product, details of the source, like what is the genus, species, what is the part of the plant use, then when any time it has been used in human, or extent of use and estimated intake. These are very simple question to answer. You need not too much worry. Similarly, if your answer comes up to C also, it is okay. You need to take only 1 to 4 parameters to answer. Okay, but if you are ending up here G, then you need to do the safety parameter like toxicological assessment and human clinical data. Okay, you need it. Answer is coming G. And if answer is H, you are not going to use it without a comprehensive risk benefit analysis. Okay? So these are a simple question to answer, and they have told that what data you need to use it in food before. Okay? So like I will give you one extract which is most commonly used in as a preservative, and this is these are the limits allowed by FDA for grapeseed extract. Okay? This is exiting as C here, if you see. Exit point is C here. Okay? Grapeseed extract, because it is not used traditionally, so is the product or ingredient is an extract or derivatives of a traditional food or ingredient? Answer is yes. Then will the proposed use lead to a significant increase in intake? No, because the concentration allowed is very less. It is, I think, 200 ppm to 800 ppm. So this, and then person will not take it too high so that it can cross the limit. So that's why it is exiting as C, and then FDA has now allowed it for food uses also. It can be used in beverages, it can be used in fats and oils, it can be used in fruit and vegetable juices or many drinks. Okay? So that's what, if once we extract a compound and we come to this safety parameter, we can use it in the product. Okay. So, so many compounds have been extracted. What are their industrial application? If you're like, again, I'm repeating this, you have selected the plant, you have done extraction, identification, and you have established the bioactivities, then the application are very wide. Like it can be used in meat industry, agro-food industry, food packaging application can be done. nutraceutical industry can be done, cosmetic industry it can use. This is the best example of any of the extract use. Like Lycored is a company based in Israel. They started with lycopene. Now they cover all these aspects like agro-food industry, nutraceutical, cosmetic, and they have a lot of products which are based on initially from lycopene extraction. You can visit their website and get acquainted with range of product that they produce. Now coming to what are the challenges in bioactive based food component analysis, like these are the market you need to know. But scientific challenges are like you need to maintain the natural requirement, and you are going to use natural source, so natural requirement is maintained. Then whether it is people consume, cultural requirement of the people, then innovative delivery format, how you are going to deliver it, what form, whether you are going to use in juice or you are going to make other value-added product, and then what specific health benefits you are going to claim. These are the challenges in development of bioactive compound-based foods. Okay, now I will show you what we have developed in bioactive-based products. Like this is the, if you see the form of delivery is pasta, fruit and vegetable-based pasta. So the fruit, the color was extracted from these, or we have added directly the different vegetables to get different color, like palak to get green color, or carrot to get orange color, beetroot to get red color. And these are rich in, this pasta is compared to normal pasta, it is rich in fiber, beta carotene, lycopene, butene, and betaline, depending on the vegetable added. And this has 6 to 8 months shelf life. And this technology was transferred to Hindustan Lever Limited has bought this technology. And then other is preservative, what we have added, extracted natural preservative and added in muffins. Okay. If you see the no preservative added muffin was lasting only 18 days, but when natural preservative was added, it was similar to the synthetic preservative. It lasted for 24 days. And this technology has been taken by MS Healthy Cakes and Foods Bangalore. They are going to commercialize this. So this again, this is the list which shows you what are the different companies which are means operational in functional fruit and vegetable products in international market. But here, just to bring to your kind notice that they are mostly added nutrients, not the bioactives what we were discussing. But nevertheless, just to tell you, there is a great market for these kind of added products also. If you see Tropicana or Welch Food or Minute Mates USA, less than USA. And if you come to Indian market also are now started coming with functional fruit and vegetable products. Okay. Like recently you must have heard because of Corona, but again it is dairy product, but and ingredient added is from horticultural source, like turmeric powder they have added, and they have made it a healthy milk. And here it is juice for real active fiber. They tell it as a fiber-rich juice. So that also is a functional product. Okay. Their main player in India are PepsiCo, then Amul, Mother Dairy, and Dabur. Okay. So this, just to conclude my lecture, I wanted to tell you there is a great market for this functional foods as well as for non-thermal or advanced processing techniques to be followed. And non-thermal technologies like cold plasma, ozone, high pressure have been studied at laboratory level, not in our, but many other laboratories they have studied. Even they have been now high pressure processing is the most studied and most preferred non-thermal technology, and products are available not in only in external means in global market, but Indian market also. And when you come to the waste utilization, then there is a product formulation needs to be optimized, like especially safety data, and then the product delivery format need to be worked out. And then further there is a challenge, because what happens, like sometime if regulations changes, if you remember last December, there earlier used to be 400 plus bioactive compounds in FSSAI list, but now they have reduced it to 396. So you need to be careful whether what you are going to add is whether permitted by regulatory agency or not. So this is all what I wanted to tell about value addition using non-thermal technologies and utilization of waste. And these are the projects, especially for non-thermal technologies. And then for bioactive products, mostly in-house projects or industry-sponsored project we have worked. This is the team for non-thermal, and these are our colleagues for working with whom I have worked for functional products. And beside this is the work of many students, what I presented. If you have any doubt, I'm happy to take the questions. Thank you.
Yeah, thank you so much, sir, for giving this wonderful lecture on this value addition in fruits and vegetable. You have said talked more about the non-thermal techniques.
Yeah, because
Sir, can you can you stop this as share screen so that
okay.
the other participant can also.
Yeah.
Okay, so thank you so much. It was more informative and a lot of science background, and then you have elaborated different methodology, how to preserve it, and even this powder formulation and so on. No, sir, thank you very much, and I'll give time for the participant to, if you have any questions and queries. I think in the morning there was a few questions were there, and I would really appreciate if you answer those questions. Which one? This in the morning session. You have copy? How to use, yeah, how to use male flower banana of cultivated banana by making devoid of bitter compounds.
No, flower we have not worked, but pseudostem we have worked there. They have, but that's what I showed in my slides. Now, what work is done in our department on different fruits and vegetables. What are the product we have made? So particularly, I will not be able to answer exactly what male flower or thing. But I showed you slides where different kind of products have been developed in our department. And beside that, the technology database what CFTRI has, that will answer many of the questions. You find that technology is there means we have a process to solve that. If still you don't find what you are looking in our technology database or free technologies, then you can contact us. We can work on that. There is different mode to work on that particular aspect. Like we go on project, like I told you, HUL product, what I saw, that was by discussion, HUL has given us the project. Then we have developed that pasta. So those kind of things is there, but that very particular answer I am not having. Debittering, there may be many methods, like people are passing through resins and getting debitted juice, but whether that can be applied to this banana flower, I am not sure. But in general, you say debittering by passing through resins, debittering can be done. That's what our department people had tried for bitter orange as well as for custard apple.
Okay, what are the value-added products which are having good market demand?
In?
The next question is, what are the value-added products which are having good market demand?
Yeah, that's what I showed. No, full this functional foods, especially with Corona, you see that this Haldi Doodh was launched after Corona pandemic started only. So anything which can give you value like immunity boosting or any health benefit, they are having very great demand. That's why my last slide was about that only. No? Like international market, so many products are there from functional food products from fruits and vegetables. But in India, very less, only fiber rich by Active Real is there, and then this turmeric added milk by our Mother Dairy has launched. So anything which has any functional property will have better demand.
I would like to know how can remove foul smell during custard apple processing. Is there any technique?
Foul smell or bitterness you are telling? Foul smell may come from spoilage. From spoilage also. So if you preserve it, generally what happens? Bitterness is a problem, and that happens when you do heat treatment. So custard apple, generally what they do, they after harvest, they generally freeze it to -18 degrees centigrade and then use it, mostly in ice cream industry. So once it is frozen, there is no bitterness doesn't occur.
The next question is, what are the value-added products that can be made from okra or bendi?
That's why I showed my first slide was there about minimally processed products. Even we have technology in CFTI which says how to make minimally processed product from more than 35 vegetables, including okra. So it's like you wash it and then cut in convenient pieces and then preserve it by different treatments. That is the best technique, what I can tell. Or otherwise, if you want to process it, then dehydration is technique. You can dehydrate and use it. But best will be minimally processing. That will have more value than dehydrated product.
Okay. So next question is, any nutrient label changes during processing?
Yeah.
Or is it possible to maintain the same nutrient composition as of fresh fruits, vegetables in a value-added product?
Yeah, that's right. Again, it will depend on the type of nutrient we are talking about. If we talk about ascorbic acid or vitamin C, it is not possible to maintain same vitamin C level in processed product as in raw product, because it is very thermolabile or even oxidation takes place. But if you talk about some of the minerals which are present, I don't think there is much difference in mineral content of fresh and processed product. So now you need to tell which nutrient you are talking about. If vitamin C, then certainly you cannot maintain it. It is going, while cutting itself, half of the vitamin C will be lost in any process.
So I would like to ask one question. So a lot of canned mutton, peas and mushrooms, and even sometimes fish and other, they preserve it in the tins and other. So will they sometime even the fish product like tins, they can directly consume it. These acids, will it have any sensitive to stomach, like the preservants?
In canned product, generally acid is not used. No, the principal preservation.
Not acid. I mean a lot of preservatives.
No, but
preservative.
Yeah, they are not added because canning itself is sufficient to kill all kind of microbes. Because when you do canning, you use 120 degrees centigrade for 20 minutes. So you don't need any additional thing there. There is no acid. Like if you say it will be slightly, vegetables we use slightly brine solution, or for fruits we use sugar syrup. So preservative is not added in can. If you say other like dried product, preservative is added to preserve it for longer time. So canned product are safe. Only thing, you don't get that much nutritional value what you get with other processes because it is high heat processed product.
Okay. So I'll allow the participant also to unmute themselves. I'll give that privilege. So if anyone having some questions, please ask directly to Nehi sir. I have given a privilege. You can raise your hand or unmute yourself and you can ask the question. Because this is a post-harvest subject, many of the students were opted it. When we did a lot of the survey among horticulture students, more than 50% students, they would like to know more about this post-harvest processing. They opt for it. So I think, dear students, it's for you, it is a golden time opportunity for you to interact. This is a subject I hope many of you have asked about it. So unmute yourself and ask if you have any related questions and doubts, you will clarify. Can you able to unmute yourself? I given a privilege to unmute yourself.
Hello.
Yeah, can you unmute anyone?
Yes, sir. Yes, sir. Am I audible, sir?
Yeah.
So first of all, thank you very much for blessing us with such an informative session. Sir, my question is a little bit basic question. That is like, is there any limitations of value-added products or value addition?
Sir, you have muted.
Hello.
Sir, you have muted yourself.
Yeah. Are you able to hear me?
Yes, sir. Yes, sir.
Yeah. Limitation, which sense you are telling? Means you need to say concentration?
Sir, as with respect to food safety, sir.
Yeah, that's why food safety is a limitation, because you cannot add anything on the food which is not safe for consumption. That I showed you slides also how to decide food, whether it is safe to add or not. And then other thing is that if concentration you are talking, because anything taken in excess concentration is not good. That one has to keep in mind. You cannot go on adding even if very high amount of functionally active things also. Okay. So there has to be that's why we do those assays. No? I showed you assays like in vitro, in vivo assay to know what is the optimum concentration for effectiveness.
Okay. So thank you, sir.
One is safety wise, one is concentration wise. It should not be safety wise, whether it is allowed or not, that you need to check. Then you cannot have very high concern, because not only the adverse effect to consumer, but cost of the product also is going to increase if you use higher amount of functional ingredients. So,
Sir, if we use some natural things in value addition, sir. So if there might be any expiration date, as we can see something in like in packaged foods, or like in some whatever we ordered or packaged food, there are like manufacture date and some expiration dates. So if we use some natural preservatives or something, so sir, is there any like expiration date in case of
expiry date will be for the product, because generally this product will spoil faster than going down the efficacy of the product, okay? Efficacy of your preservative. But there are some processes which can delay the degradation of your bioactive components. So like you must have heard about encapsulation. Have you heard about encapsulation?
No, sir, not exactly. I'm sure about that.
Yeah, encapsulation is a technique where you can coat your active material so that it is prevented from environmental effect like light or air. Okay, so that can be done. But the question here is, when you add in the product, then expiry date becomes for the product, because product is going to spoil faster than your bioactive compounds. Okay. Suppose you add in juice, juice will have 6 months or 4 months shelf life, but sometime your bioactive compound will be active for more than 1 year also. So now expiry date comes for the product, not for your value-added product, value-added bioactive compound. Okay.
Okay, sir. So thank you for your response.
So is there any other question?
Ruxana Bano, some raised hand, something is coming.
So anybody want any clarification, please?
Good afternoon, sir.
Yeah, good afternoon.
Sir, my name is Kyali Ghosh. I am speaking from Uttar Ganga Krishi Vishwavidyalaya. So my question is that I am recently doing my research work in okra in post-harvest technology. So sir, can you suggest me some good packaging materials that can increase the shelf life of okra?
Fresh okra, you are telling?
Yes, sir.
Means you are using as LDP? What
yes, sir. Yes,
LDP?
sir. But LDP and HDP. But apart from that, sir, can you suggest like few more?
Generally, LDP is only used, and then you can do ventilation to increase the slightly. Yeah, you can standardize the ventilation percentage, how much percent ventilation you want to get. That can be done, and lower temperature storage to extend the shelf life.
Thank you, sir.
Sir, one more question from here. How can we increase our post-harvest processing from 2% to more value?
Yeah. You meant to say how percent of processing, how can it be increased? Huh? By increase, what you say, because generally nowadays people prefer more of the fresh products. One factor is coming, earlier it used to process, now fresh is more preference. But anyway, by using more of the infrastructure, if you increase, that is going to increase the processing. The only thing is infrastructure has to be increased either by government or by public or private organizations. But as consumer level, generally consumer prefer fresh more than processed product, especially in fruits and vegetables.
Yeah, Rukshana Bano, you have raised your hand. Do you have any question? Yeah, Lokesh Yadav.
Not clear. Lokesh, not clear.
I am from AMD.
Your voice is not audible. Your voice is not audible. Lokesh, you have any question? No, Lokesh, actually your audio.
You can type, Lokesh. I can answer up to typing also.
Yeah, that's the best way. Rukshana Bano, do you have any question? You have raised your hand. Okay, I think Lokesh is having some problem.
Okay. Otherwise, please share my email ID with the students. If they have any question, they can ask.
Yeah, sure. They can also interact.
Yeah.
Sir, thank you so much, sir, for giving your valuable time to nourish our students with this value addition and processing fruits and vegetables. Thank you so much, sir, for your valuable information. And students, dear participants, I request every one of you to give your attendance today itself. Before 6:30 p.m., the link will be sent to you by organizing secretary, Dr. Bhargav, and respond to that email immediately. And we have a YouTube link also. It will be available to you and watch later on. And there will be a questions from each session, so 5 questions. So those who scored more than 30% of marks, they will be eligible to get the certificate. So your feedback form and that marks is value because it's online mode. We have to check your that quality deliverance and how you have received that material. So it's the time to look if you have any really trouble, and you can watch on a YouTube. Okay. So I think he has typed that question, Lokesh. Sir, I'll ask you, it's maybe the last question. Okay, so how to increase the shelf life of pointed gourd?
No, that's why low temperature.
This question is how to increase the.
Yeah, it's a fresh. I think he's talking about fresh pointed gourd, but the basic thing is to keep at lower temperature. to store at low temperature, there will be increase in shelf life.
Okay. So thank you so much. Thank you so much, Logis. And finally, you typed that question. Okay, so I request everyone to start your video for our record. I request everyone, please start your video, and I'll be capturing them. And then now with this, we will end today. You just start your video.
Can I?
Okay,
can
thank
I
you.
leave now? Dr. Babu, can I leave?
Yeah, sir, for 30 seconds, 30 seconds only, please.
Okay, no problem.
For 30 seconds.
Okay.
Just I'm taking the snapshot. Thank you so much for starting the video. I want to, it's our record for your attendance. Okay, thank you so much. Thank you so much for joining with us. Thank you, sir.
Thank you. Nice.
I'll end the meeting now. Thank you. Thank you, everyone.